Now, let us play a game, children. I will tell you a letter. You need to tell me how many matchstick you know, right? Yes. How many matchstick would you require to make that letter? I will tell you a letter. You need to tell me how many matchstick would you require to make that letter. Okay? This letter is A. Capital A. Tell me how many matchstick need to require to make capital A? 3 matchstick, right? Yes, 1, 2 and 3. Next is capital C. How many matchstick require to make letter C? 3 matchstick, right? Yes. Next is capital L. How many matchstick require to make capital L? 2 matchstick, right? Yes. Then capital M. How many matchstick needed to make capital M? 4 matchstick, right? Yes, 4 matchsticks. Next is capital S. How many matchsticks needed? 5, right? Yes, 5 matchsticks needed to make letter S. Okay. Next is capital L. Here how many matchsticks needed? 2 matchsticks, right? Yes. 2 matchsticks need to make 1 L. Then tell me how many matchsticks needed to make 2 L's? 2 L's. 4 matchsticks, right? Yes. Then tell me how many matchsticks needed to make 3 L's? 6 matchsticks, right? Yes. Then tell me how many matchsticks needed to make 4 L's? 8 matchsticks, right? Yes. And for making 24 L's, how many matchsticks needed? Tell me. How many matchsticks needed for making 24 L's? Is it easy to count number of sticks, children? It's quite difficult, right? For making calculations easier, here we can use algebra. Here we can make use of algebra. It will make calculations easier. You can see repeated addition, right? To make 1L, 2 matchsticks are needed. To make 2Ls, 4 matchsticks are needed. To make 3Ls, 6 matchsticks are needed. To make 4Ls, 8 matchsticks are needed. Here you can see repeated addition. We all know that repeated addition is nothing but it is multiplication. Here 2 is a constant in all case, right? Yes, in all case 2 is a constant. We can observe a pattern here, right? Yes. The number of matchsticks required is equal to 2 times the number of L's. The number of matchsticks required is equal to 2 times the number of L's, which is equal to 2 into number of L's, which is equal to 2 into n. Here n is a variable. We have created a formula for this. This makes the calculation easier. Let's check it, children. Making 40 L's. How many matchsticks required? It's a huge number, right? Yes, since we have formula. So, we can easily calculate by using the formula 2n. What the value of n here? 40, right? I'm asking to calculate the number of matchsticks to make 40 L's. So, number of n, that is the value of n is equal to 40. So, we can calculate 2 into 40 is equal to 80. So, 80 matchsticks are needed to make 40 L's. Got it? we can do some exercise questions, children. The rule which gives the number of matchsticks required to make the following matchstick patterns. Use a variable to write the rule. First problem is pattern of letter T as. Okay, I will explain one by one. First question, children. How many matchsticks required to make capital T? Capital T. From the figure, you can observe that 2 matchsticks needed, right? Yes, 2 matchsticks needed to make a letter T. Hence, the pattern is equal to 2n. Here, 2 matchstick is a constant, right? So, 2. N is a variable. It depends upon number of T's. Okay? So, the pattern is 2 into n, that is 2n. Second question, pattern of letter Z as. From this figure, you can observe that 3 matchsticks are needed to make a letter Z, right? Yes, 3 matchsticks are needed. Hence, 3 is a constant. Hence, the formula is, hence the pattern is 3 into n, which is equal to 3n. Third question is U. Pattern of letter U. This figure, you observe that 3 matchsticks are needed to make letter U. Hence, the pattern is equal to 3n. Next, the letter V. Here, how many matchsticks are needed to make V? 2 matchsticks, right? So, the pattern is equal to 2n. Next, pattern for E, capital E. From the figure, you can see that 4 matchsticks are needed to make capital E. Hence, the pattern is equal to 4n. Next, the next letter is S. From the figure, you can see that 5 matchsticks are required to make letter S. So, the pattern is 5n. Capital A. From the figure, you can observe that 3 matchsticks are required to make capital A. Hence, the pattern is 3n. Children, here I am going to ask a question. Let us consider letter capital E. How many matchsticks are needed to make one E? 4 matchsticks, right? Then tell me, how many matchsticks are needed to make 5 E's? How many matchsticks are needed to make 5 E's? Here we have to make 5 E's, right? So the value of n is equal to 5. Then what you will get? Then you will get the number of matchstick. 4 into 5. What's the value? 4 into 5 is equal to 20. So 20 matchsticks are needed to make 5 E's. Got it, children? Next question. If there are 50 mangoes in a box, how will you write total number of mangoes in terms of boxes? How many mangoes are there, children? 50 mangoes, right? Yes. Use B, small letter B for the number of boxes. If there are 50 mangoes in a box, how will you write the total number of mangoes in terms of boxes? Here the solution is, let B be the number of boxes, small b. Here B is used to represent the number of boxes. Number of mangoes in a box is equal to 50. Then total number of mangoes is equal to number of mangoes in a box into number of boxes, which is equal to 50 into B, which is equal to 50B. That is the solution. Similarly, the third question. The teacher distributes 5 pencils per student. Can you tell how many pencils are needed given the number of students? Use small letter S for number of students. Here the solution is small letter S be the number of students. Pencil given to each student. How many pencils? 5 pencils, right? Yes. So pencil given to each student is equal to 5. Total number of pencil. How many pencils are needed? Yes, total number of pencils is equal to number of pencil given to each students into number of students, which is equal to 5 into number of students. That is 5 into S, which is equal to 5S.